Alright, so this video is about ellipse, which is a type of conic section. First of all, if I didn't mention already, conic sections, or what we call in math, or more importantly, as we build into calculus, because it's a really important topic in calculus. It's parabolas, circles, ellipse, and hyperbolas. And each one of these are formed with this double cone. So basically, if you have this double cone here, we think about three-dimensional space. If I put a plane through this cone horizontally, it's like horizontal to the ground, it will make a circle, which is a special type of ellipse. So technically, a circle is a type of ellipse. If I slanted that plane in any kind of way, I'll create this oval shape, which is the ellipse. All right. So circles have some properties ellipse don't have, but all the properties of ellipse circle have. Parabola, if I took this plane and sliced it through in such a way that I created this curve, it had a parabola. And if I took the plane, I sliced it in such a way that I had a curve on top and a curve below, that would be the hyperbola. That's the next lesson after ellipse. But right now we focus on this topic, which is the ellipse. Basically, it's this oval. It could be facing sideways like this. It could be drawn in such a way that it's like egg-shaped. So it could be facing up and down this way. So I think about this being football shape and this being an egg shape. But basically, in this ellipse, you have special things happening. One thing you have is a center. In this case, this would be my center. Along the center, we have this axis, which is called my major axis. The shorter version, that would be from connect this point to this one. We'll call that my minor axis. Minor axis. All right. Now, the points here on the outside that are furthest away is the name for those points. These points are called my vertices. One is a vertex. The other is also a vertex. Together is the vertices. And those are the ones that are farther away. The ones that are closer together, we call those co-vertices, or co-vertex, for one. This is a co-vertex. And basically, some other important facts about it is, in between here, these 2 points, I'm going to call this point my focus. And there's 2 of them. There's one there, and there's one here. So focus. Plural is foci. Plural is foci. It's 2 focuses, or more than one focus. All right, so those are all like really important topics of the ellipse. So I'll get all that copied down someplace, and we're going to talk about how we can find each one of those special places in the ellipse and why they're important. All right, so sometimes the center is on the origin, sometimes the center is elsewhere. So the center is up here, no matter where the center is. The center of this ellipse is the coordinate HK. If at the origin, HK are both 0, my purpose made this one not at the origin, someplace else. So that center there is HK. And basically what we know is in an ellipse that the length from the center to the vertex is A. So that could be the center to the other vertex. Still saying like A. Meaning that this major axis from here to here, major axis is equal to 2A, or twice A. Alright, so I thought about the shorter direction, which would be the B direction. The co-vertices directions. Alright, so if I thought about from there to there, that length would be B, and this length would be B. Meaning that my minor axis is equal to twice B. We're going to talk about what A and B are in the equation of ellipses in a minute. And the last thing is the focus. It's on there as well. So the focus will be around here. And I would say the length from the center to the focus is C. So if you have another focus over here, that length will also be C. So if you connected the foci, the distance that we twice see. All right, anyway, it's a lot of little stuff happening there. Let's talk about the equation of ellipse. The general form, standard form for ellipse is x subtract h squared over a squared plus y subtract k squared over b squared equals 1. It's always equal to 1. Could also look like this though. X subtract h squared over b squared and y subtract k squared over a squared, and that could also equal to 1. The difference between these two equations is the a value is beneath y or x. All right, so if it's this way, it's football shaped. That means that the longer segment goes horizontally, goes left to right. The longer segment, the major axis, goes from left to right. If it looks like this, egg-shaped, this means that the longer segment is going up and down, so it's more like this graph. Or it might be shifted from the origin elsewhere, but it's going to be an egg-shaped ellipse. And that's the difference between the two. So with the ellipse, remember this. A is always larger than B. And this is for ellipse. A is always larger than B. So if you ever want to figure out which is which, figure out which one is larger after you square them, and that's going to be A. All right, so moving on. All right, so the example says graph the ellipse formed by the equation here. All right, so if you're looking at this equation, general form for ellipse, h is always with x, k is always with y. So this is in the form x subtract h squared over a squared plus y subtract k squared over b squared, and that's equal to 1. And I know that a is beneath x because 16 is bigger than 9. So I know that a is there. And I know it's a football-shaped graph. So if I thought about this, I know my center, HK, you have to get the opposite of these signs. So if this is a -2, it's a +2, and that's a +3 is a -3 for my center. So then my center is at +2, -3. So I'm going to go over to +2, down to -3, that's like right here. That's my center of that ellipse. Now, the a value, I know a squared equals to 16. So if that's true, if a squared has equal to 16, or I know a has to be the square root of 16, or 4. So I know a has to be 4, meaning that from that center, I need to go over 4, and a is beneath x, so I need to go over 4 in the x direction. So this is at 2, and then go over 1, 2, 3, 4, puts me at 6. If I go over 4 to the left of 2, puts me here at -2. All right, so this is a vertex, and this is the other vertex. All right, now once you get the co-vertex, I know enough to graph it. If I know that b squared is beneath the y value, so I know b squared equals 9. So I know b has to be 3. So I know from the actual y coordinate, I need to go up 3 in the y direction. So this is at -3. I'm going to have to go up 3, so that's 1, 2, 3. That's what you hear on the axis. I'll go down 1, 2, 3, puts me down here. So if I made my ellipse, we have to connect these dots. Kind of an elliptical fashion. And voila, I've graphed the ellipse. So the direction just said graph it. We can graph it just using what the center is, h and k, and that's how you graph an ellipse. All right, let's go further. All right, so new example says graph the ellipse formed by the equation here. And you might notice that it's not a standard form. For one, it's supposed to be equal to the number 1. It's not equal to the number 1. So the first thing I want to do is make it equal to number 1. So the question is, how could you make this 144 become a 1 without subtracting 143. So think about that. Pause the video and think about what would you do to make this 144 become a 1, positive 1, without subtracting by multiplying or dividing by numbers. Okay, so you might have thought about, well, I could divide everything by 144. And you're right. Divide that by 144, divide this by 144. Divide each term by 144, we're going to make it so that it's not going to be a 144, there's going to be a 1. So 16 divided by 144, I want to say that's 9. Let me see that. Yeah, it's 9, but it's really 1/9. So I'll call this 1x squared over 9 plus 9 goes in 144. Well, apparently 16 times, if that's what happened. So this would be 1y squared over 16 equals to 144. 144 is 1. Now, I don't really need these 1s here, so I can just drop it off and call the x squared over 9 plus y squared over 16 equals to 1. Now, what I need is my center. I need a and b. So let's look at this. Where do you think the center is? Well, there's no h and k being subtracted, so the center must be 0, 0. All right, because apparently that's x subtract 0 squared. This must be y subtract 0 squared in order for it to be just y squared like that. So that's true. All right, so I know enough to figure out what my center is. So the center is at 0, 0. So I got a big dot here at 0, 0. And then I need to know a and b. In this case, apparently the bigger number is 16. So a squared has equal to 16. So a has to be 4. And the bigger number is beneath y. So I need to go up 4 in the y direction. So in the y direction, I go 4, puts me on 4, and on negative 4. The b value, b squared, has equal to 9. So b has to be 3. So I need to go over 3 in the x direction. So 3 puts me here and puts me there. All right, so if I made my ellipse, it looks something like this. All right, so that's how I can graph the ellipse. I'll put it in standard form first. All right, last example. All right, so this is the last example. Write the equation here in the standard form for an ellipse. So what I want to do is, first of all, rewrite this equation. All right, I see that at some point I'm going to have to complete the square because these are going to be numbers that I got to complete the square with. So begin, I'll move this 24 to the other side by subtracting 24. Dealing with this line. Now, this is ready to complete the square, but this isn't. I don't need a 4 in front of x squared, so I'm going to factor out that 4 and make it this. I'm going to factor out a positive 1 here. I mean, I don't want to change it. All right, now look at this, and I see what the c value has to be when I complete the square. All right, well, that's going to be now 4x squared subtract 6x plus half of that squared is 9 plus y squared plus 4y plus 4. And that's going to equal to negative 24 plus 4 times 9 plus 4. We need a new space. I'm going to erase this screen and write it on a new screen. So I'll pause it and copy everything I have up to now. I'm about to erase this. Now this is what we have. And this 9 over here has a 4 in front because that 9 was being multiplied by 4. Now this is factorable. All right, if you factor that, look for what multiplies be 9 and add be negative 6. But that's x subtract 3 times x subtract 3 plus, this is factorable. It's y plus 2, y plus 2 is equal to 16. I'm about to divide all of this by 16. All right, this can be called squared, this can be called squared, and divide everything by 16. Leave me with this. And this is standard form. And that's it. That's all I have. Good luck.